Welcome to the first video. Today we're going to learn about reinforcement learning. We're going to use the terminal and we're going to start by pip installing sol, numpy, and gymnasium. Put them over here. Alright, so now let's import. So we're going to import gymnasium. We're going to have it as gym, and we're going to import numpy, and we're going to have it as np. Okay. Now, later on, we might end up using the CSV module, but we'll use that in function to keep it less confusing for you guys. Let's start by creating the environment. So for now, we're going to use an environment where we have a mountain and a car, and the car tries to scale the mountain. It's a great introduction environment. And equals gym.make. This one's already made for us, don't worry about it. You're going to type mountain car v0 and then have it as render mode equal to human. Don't worry about this. Next, we're going to add some hyperparameters. These are basically just things that we normally tweak. So let's have the learning rate be equal to 0. Let's do 0.001, and discount factor of 0.1, and let's call it exploration rate of 0.2. This can also be called ellipson, but we're going to call it exploration rate because it's more commonly used. Now let's create our project dataset size. So we're going to use 20 by 20. So discrete read OS size. It's called this generally. So we'll use this to avoid confusion when other people are looking at our code. And now we're going to create the discrete OS when size, and that's going to be our environment communicating to us. So observation space I and minus environment observation space low. Now we're going to initialize our Q table. Initialize Q table. We're going to use Q table equals np.random.uniform. So we're using our numpy module. We're going to get the low is going to be -2. So this is how the lowest value I might pick. The high is going to be equal to 0. We don't want anything to have a positive reward just yet. And then we're going to get the discrete OS size, and then we're going to get the discrete OS when size as our other parameter. Now we're going to create a function. This function is going to be used to get the current game state. So we're going to get the discrete state and then have action state as input, then discrete state will be equal to state minus our environment observation space dot low divided by our discrete OS when size, and then we're going to just return the value in tuple format. Next, we're going to set our discrete state. So our discrete state will start at discrete state, and we're going to use state as input. No, we're not going to. We're going to use environment reset to reset the environment, and then we're going to get 0, index 0, and set that to our discretion state. Is most AI logic has a while loop. Here, we're going to loop through the environment. So first, we're going to create a done variable. We're going to set it to false. Then we're going to have a while loop, and it's looping while it's not done. Then we will do our actions. So our first one is if the AI wants to exploit or explore. So if so since we have our exploration rate, if our np random is greater than our exploration rate, then it will choose to exploit. So our action will be our maximum. So action equals np dot our max q table, and then discrete state. Now we're going to use our now we're going to create the else logic. For the else logic, we're going to do action equals explore. So np dot random dot randit 0, comma environment dot action space dot n. So that will just explore and choose a random option. So here, it's really great to use the example where each action equals a value. So given a 3x3 grid, we have 1, 1, 1, 2, 2, -1, and then we have 10 here. So normally, it would just, the AI, if it sees the first time it gets a positive reward, it will just continuously do this. If it explores, it might do this, then decide to go this way. That's a 1, maybe I'll go this way. And eventually, it will try all the options and figure out the 10 is the best route. So it might end up going to the fastest way possible to 10. This is a very simple version of our AI code. What we're ending up doing is we're teaching the AI at what coordinate should it go up, and what coordinate should it accelerate and decelerate or go backwards. And so we have a little bit more options, which will mean it's slightly more complex, but it's more, it has more of a real world application. So later on, we might learn more about, if you choose to stick around, we're going to learn about how we can apply this in the real world. So next we're going to we're going to interact with our environment. So essentially what we're going to do is we're going to return we're going to get the action, and we're going to update our state, reward, and done. Our environment is going to store all our info, so we'll be able to update it regularly based on our discrete state and update the Q table. So first, we're going to do new state, reward, done, comma, underscore, and then we need truncated. And this is going to be info, and that's going to all equal our environment when it's stepped. So basically what we're doing here is we're going to use, for now, a built-in step function. In the future, you might end up creating a random class. So let's do class example, and we might have an init. And here we just have our variables. So, for example, so here it's just simple example. We have our variables, and those are equal to any value. We'll just have it as not implemented for now. What if we, and then we can create our functions. This one will be step. We have our step logic. And all the other functions here. So anything we're using in this AI code would have a place here. Like for example, make, we would use that here, and we'd create our own environment. Just to show you how that works, I'll open up an example file. So here we just have our step, our render, our reset, and our init function. This is our simple environment, and depending on what you want to. So here you can see we have an init function, that's going to be our variables. Our reset function will be our how we can reset the environment. We'll return all the possible actions, and then we'll use the step function. That's going to get these variables and then return our variables. So Jim does actually, in this environment, return truncated along with info. You can see these two states are rarely used. You don't have to worry about them. Okay, returning back to our example, we're going to get our step function. After that, we're going to get our new discretion state. So new discrete state, and that's going to be equal to get discrete state, and then new state. Now we're going to get our goal position, and that's going to be environment.unwrapped.goal position. After doing that, we're going to create some basic logic. So if it's not done, then we're going to do something. If not, it will reset the environment. So we'll basically exit. So new state equals 0, then it's greater than or equal to environment.goal position, and then we're going to pass so oops, use step, that should be state. So if it's not done, we're going to have our max future q here. This is going to be one of our variables in our calculation. We're going to use np.max. We're going to get the q table, new discrete state, and then we're going to get the current q and the new q, and this is just going to update our q table every iteration that we need to do. The discrete state plus our action. Give me a minute. Made a little whoopsie in the spelling department. And then we're going to have our new Q. Q be equal to 1 minus the learning rate times our current Q plus our learning rate times our reward plus discount factor plus times our max future Q, and then we're going to get the Q table. So from here, we'll do Q table discrete space plus action, comma, equals new Q. Now let's work on the aleph. So if you didn't know, pass is just a placeholder. It's great for outline. You should use it often. It just means that Python will ignore the rest of the logic and move on. So you'll see there's an error when I delete it. That's fine. You can ignore it. What we're going to do next, we're going to have the Q table, and that's going to be the discrete state plus action. And that's going to be equal to 0. Now let's update our discrete state. So our discrete state will be equal to our new discrete state. Now let's create the logic for once we're done. So environment.close, but first we need to render it. So environment.render will render it, and environment.close, we close the environment. Now let's move on to bonus. Bonus 1 is to add a progressively lowering learning rate. So our exploration rate, so exploration rate will gradually decrease. So exploration rate times equals 0.999. So this will mean that every iteration, exploration rate will gradually decline as we know more and more. So this will allow us to have a faster code. We might also create a maximum small exploration rate. So let's just say if exploration rate is less than, say, 0.1, then exploration rate equal to, let's just say, 1.9, and we'll just have it like that. Next, we can even go even further and make this value smaller, and we can make this greater. So we can instead decide to make our exploration rate extremely high. So it will try all the options. So it will be very slow at first, but it will gradually speed up, which will mean in the long run it will be faster. Then we can also try and make this into an inline statement. So if you want to go even further, exploration rate equals exploration rate times 0.999, and then we're going to have it if exploration rate is greater than 0.1, else exploration rate times, let's just have it maybe times 10. What you could also do alternatively is have it expiration rate, it equals 0.1 or 19. This will allow us to go even to have faster code and have cleaner code. Now, let's move on to bonus 2. Bonus 2 is going to be adding CSV. So you can do two things. You can import CSV at the top, or you can import it within the function. To avoid errors, normally you're going to want to add it at the top, so let's add CSV. You can also do it within functions, but if something happens and you accidentally import it at the top, then you'll have a bunch of errors. So import CSV, and let's create two functions. One is going to be to save the cube table, so save cube table, and we're going to need the cube table and the file name and pass, and then we also need to load it. So load cube table. This will be file name. Let's have file name up here. Let's say I'll call it final cube table dot csv. Make sure to include the path. So here's mine over here. So we have the CSV, have our file name. Mine's going to be final qtable.csv because we don't really have any, we're not going to really update the version, so I'm guessing you won't either. So what we're going to do is we're going to first work on the writing one. So have you ever, we're going to use the with function. We're going to open it with the file name. We're going to use the mode W, and then we're going to have new line equal to to blank space, so we have everything separated by a string. Now we're going to have writer equal to csv.writer file, and now we're going to have for row in queue table, and we're going to write our row. This will update every single time you run, so it will progressively get better. Now, let's create a load function. So, given the input file name, we're going to give the output of the file. So, the cube tables can be a blank list. We're going to use the with open function, and then we're going to have file name mode equals R, and we're going to just have it as file. Reader is going to be equal to csv.reader. We're going to use the module csv. We're going to use input file, and then for row in reader, we're going to have qtable append row. And then what happened here? We're going to append the float value for value in row. And at the end, we're going to return the cube table. Alright, so next, to continue with bonus 2, we're going to use our functions. So first, we're going to use the load function. So we're going to try and load in. So if the file exists, we're going to do qtable.load. If we get a file not found, we're going to create a new one, and we are going to save it and using the file name, and then accept And then if we have an exception, they are going to print error, and we'll just have the Q table here. I'm not sure what type of error there is, but if there's any, you can message me or comment on YouTube video or Medium article based on this. Now to continue, we are going to save the Q table once it's finished. So save Q table, and we're going to use Q table and the file name. You might be able to find this tutorial in other places, but it's not updated, and you'll find that it won't work. There's a variety of reasons why. The gymnasium function was updated. The gym function became gymnasium. It got new values. The environment was updated, and new methods have been found, and there are new bonus things we can do, and those will improve your code. I hope this helps, and I hope you join me in my journey to learning about machine learning and Python.